Now we are going to discuss about the next concept called subnetting. So which is in a main topic where we are going to discuss now how this subnetting is going to be help us in minimizing the size of IP addresses. So first we'll talk about what is subnetting. So subnetting is nothing but where we are going to divide one single large network into multiple smaller networks. So where it is going to help us in minimizing the wastage of IP addresses whatever we have. Okay, so let's take an example here. If you have some department, let's say in your organization, you have some IT department, sales department, marketing department, and some HR department. Okay, so each and every department, they have the requirement of 50 users, let's say. Okay, sales department 50 users, marketing department 50 users, and here HR department also 50 users. So if I don't want to communicate with each other, so I would be requiring to use different subnets, right? So here I'm going to assign the subnet of 192.168.1. network, and here 192.168.2. network, and here 192.168.3. network, and here 192.168.4. network. So this address belongs to C class address, where it is going to be supported around 2 power 8, which means 256 addresses, right? So in each and every subnet, it is going to be support around 256 addresses. So from in this 256, I would be using only 50 addresses in each and every department or each and every network. I'm using here only 50 addresses. So 256 minus 6, 50, remaining 206 addresses on each and every network. Simply I'm wasting, right? So if I count this all, it is going to become 800 plus addresses. Simply I'm wasting here, and I'm not able to use anywhere these addresses in my network, because again if I use these addresses for another departments, okay, so they will communicate with each other, right? So simply I'm wasting this. So by using the concept of subnetting, we are going to divide one single large subnet into multiple smaller networks, and we are going to allocate to each and every department. So this is what the concept of subnetting. So in order to perform this subnetting, we have here two methods. One is an FLSM and another one is VLSM. So here FLSM stands for fixed length subnet mask information, and where VLSM stands for variable length subnet mask information. So fixed length is like, where we are going to divide the network into same smaller networks. The network size will be same, okay, like your classrooms. If you take an example of FLSM, it like your home. So where the network might be equal, may not be equal. So you may have one big hall, two equal size bedrooms, and one small kitchen and one bathroom, etc. So like sizes may be equal, may not be equal. That is what the concept here, VLSM, variable length subnet mask information. So you will be seeing here same thing on the slides. So where we are going to divide one single large network into multiple smaller networks, where it is going to be help us in minimizing the wastage of IP addresses whatever we have. And in order to perform this subnetting, so where we are going to convert the host bits into network bits. So here, in order to perform this calculation, we would be having some formulas. So if your requirement is with host, we would be using a formula called 2 power h minus 2 greater than or equals to a requirement. So this will be the formula. Based upon these two categories only, we are going to perform the concept and calculations of subnetting. One is VLSM and another one is FLSM. So, and this is one table called 2 power table. With help of this 2 power table, we are going to divide the network into possible sizes. So, which is 2 power 1, 2 power 2, 2 power 3, 4, 5, 6, 7, 8, 9 up to so on. So, the possible sizes for this one is 2 blocks, 4 blocks, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 8192, 16384. So based upon these possible sizes, we are going to divide the network. Okay. So here where we are going to convert the host bits into network bits, that is nothing but zeros into ones. Okay.